Here's the second part of acceleration, learning direction of acceleration. Acceleration is a vector, therefore there is a sign to represent the direction of acceleration. And this is important to notice that, underline, we cannot find out whether an object is speeding up or slowing down just from the sign of acceleration. What do I mean is, have a look in this figure. Case 1 is easier to understand because it takes the right hand sign as positive. So read by yourself. And here, pay attention to case 2 because in this case, we're taking left hand side. Moving to the left is positive. Therefore, to the right means negative. And this person is running to the right. Therefore, at the beginning, its velocity is 0. And then, because moving to right, the velocity now with a sign negative. And he is speeding up to 10 meters per second. Therefore, the acceleration, the magnitude of acceleration is by this formula, v minus u over t. Okay, and then you can find 5 because it is moving to the right, and we should have a negative sign here to represent moving to the right. And you can see, can we tell if the acceleration is negative? It is slowing down. I repeat, can we say because acceleration is with a negative number, that means it is slowing down? Of course not. You can see in this picture, this man is speeding up. Therefore, remind you once again, the sign of acceleration does not mean it is accelerating or decelerating. Decelerating means slowing down. And one more conclusion you can find in this picture is, underline, when the acceleration and the velocity have the same sign, which means here, positive sign, negative sign, opposite sign, right? Opposite sign here. But if they have the same sign, both positive or both negative, then we can draw a conclusion that this object is speeding up. In other words, if they are having the opposite sign, they are slowing down. Alright, next here is a common example in DSE. When you do this question, it's better for you to write down UVAT besides, and then you write down one by one from the question. For example, a football moves towards Tony at a speed 2 meters per second. So this is the initial velocity, and then I will write down this is u equal to 2. And then he slowed down the ball at a rate of 25 meters per second square. And then you can see the unit per second square here, meaning the acceleration. And remind that don't write down 25 because the ball is slowing down. Slowing down means the acceleration is in opposite direction. So remember, we have to put a negative sign here. And then you are asked to find, assume the ball moves along a straight line, and then you are asked to find how long we will take to stop the ball. Stop the ball means at rest. Finally, the final velocity here would be 0. So v is 0. And then you are asked to find time. What is time here? Okay, and then you can do it by acceleration formula, and you get the result. Next part is about a whole picture of acceleration. Have a look here, showing 60. This picture shows 8 seconds. of a car, and in these 8 seconds, it is undergoing acceleration uniformly, or we call it uniform acceleration with -2 meter per second square, which means on screen, from time equal to 0, after 1 second, it will decrease by 2 its velocity, decreased by 2, decreased by 2 for every second. And then, of course, here becomes 0. And after that, okay, from 4 to 5 seconds here, again continue to decrease 2, -2, -4, -6, -8. And this negative sign, okay, from the time 5 seconds to 8 seconds, it means the car is moving backward. So now you have to pay attention to the sign of velocity and the acceleration. The sign of velocity, okay, show you now the car is moving into which direction, and the sign of acceleration show you in which direction the car is accelerating. In this 8 seconds, the whole picture, okay, the whole event, the car is accelerating uniformly. Accelerating uniformly means the whole process keeping the same, decrease 2 meter per second every seconds, okay? And look at time equal to 4 seconds. Well, this is very important because this happens all the time in the question, asking, at this moment, does the car undergo acceleration? Because this show you v equal to 0 and ask whether it is undergoing acceleration. What do you think? Well, I'll give you a hint. At this moment, we call it momentarily arrest. Means at this moment, it is arrest. Okay? At this moment. Alright? But is this car undergoing acceleration at t equal to 4 seconds? Alright, you can have a hint on next picture, on next page. And then it's time for you to finish page 13. And if time, finish page 31, and we will have an assignment on the lesson tomorrow.